Hello and welcome, I'm your CodeMonkey. In this lecture we're going to begin building one of our main game mechanics. We're going to make a kitchen counter and handle the logic for the player to be able to interact with that counter. Okay, so let's begin by making our kitchen counter. And just like we did when we made the player, let's first make an empty game object and place the visual inside of it. So let's right click on the hierarchy, create an empty game object, call this the clear counter, so it's going to be clear on top so we can place and pick up objects. Let's make sure to reset our transform, so let's put it on 0, 0, 0. Let's move it just a little bit, just so it's not exactly on top of the player. Okay. Now inside, let's add the visual, so let's go inside the assets folder. And then over here, we've got the prefabs visuals, and inside we've got the counters visuals. And over here, let's find the clear counter visual. So let's go ahead and drag it inside the game object. Again, make sure the child visual is on 0, 0, 0, the local position. Okay, great. Now, just like we did in the last lecture, where we added collision detection, that should already be working by default, but in order for it to work, it needs a physics collider. However, note how the visual over here, there's no collider, and inside there's no collider, there's only visuals. Again, this is the same thing that relates to separating logic and visuals. Basically, the visual prefab, this one only has visual components, so only meshes, animations, and that sort of thing. And the main parent game object, this is the one that is going to have all of the logic components. So that means any kind of scripts behavior as well as any colliders. So over here on the parent game object, let's add a new component. Let's find a box collider. Again, make sure you add a box collider, not a box collider 2D. And I chose a box collider just because this is the shape that makes most sense for our counter. And now let's scale the box collider. Again, that's the box collider, not the transform, so leave that one with the scale of 1, 1, 1, that's good. And over here on the box collider for the size, let's put it up with a size that fits the visual, so 1.5, 1.5, 1.5. And finally, we just need to lift it up a bit. Over here on the scene view, you can see those little green tiny lines. These refer to the box collider shape. So let's lift it up by a little bit in order to make it perfect. Let's put it up by 0.5 on the Y. Alright, so there you go. That one does have the perfect shape. If we test just like this, it should already be working. So okay, so here's my player, and if I move towards it, and yep, there you go, it does work. So it is a solid object. I cannot go through it. Okay, great. Let's just visually rotate the collider. So let's do that, and again, for rotation, let's make sure we rotate the parent game object and not the visual. We want the visual to be on rotation 0, 0, 0. Okay, great. So on the parent game object, let's just rotate it around. By the way, here's a quick Unity tip. If you want to rotate, hold down Control and then click to rotate. And now instead of rotating on every angle, it goes on a 15 angle increment. So just hold down, and this way you can easily get it to 180 degrees. So that's just for fun, just to make it face the player. Okay, great. So now let's interact with this counter. And doing this is actually super simple. We already learned how to do a raycast to handle collisions, and for interactions that's exactly the same thing. So let's go into our player script, and we're going to do a raycast to handle that. But before we do, let's organize our code here. Let's make a proper function to handle our movement. So let's make it private, since this is going to be a local function. Return void and call it handle movement. And then inside, let's put all of this code. So let's copy all of this, put it in there, and then on update, we simply call this function. Okay, great. And now let's make another function. So private void, let's call it handle interactions. And we just call this function on our update. Okay, great. Everything is much more organized. So now here, let's do a raycast. So once again, go inside physics, do a raycast. For the origin, let's start on transform.position. For this, obviously, we want the move direction. So one approach would be to make this a field variable sorted up here, so that way we can access it in both functions. However, if you remember how we handled the whole issue with the diagonals, basically we're modifying the move direction. So if we're moving diagonally, then this one modifies to only move left or right. We don't want that for the interaction. We want pretty much the exact same one, even if it's pointing towards a solid object. So let's not make this a member variable and reuse it. Instead, let's just grab it again, create it again over here. So we get it, and we want this one even if it's pointing towards a solid object. So let's use this as our move direction. And now for the distance, let's define a fixed distance. So something like 2 units would work. And also here's another very important lesson with regards to writing good clean code. So you would think to write code like this. So let's put the 2 right in here. That would work, everything would work perfectly. But then let's say you get back to this code after 1 week. Would you remember what this 2f means? The answer is probably not. You would probably very easily forget exactly what this means. So because of that, you should never use numbers directly in the code like this. Instead, you can either make a field up here if you want to make it customizable, or much simpler is actually what we already did previously. So let's define a local variable with a proper name. So let's define a float, and this one is going to represent our interact distance. So let's call it exactly that, interact distance, and let's put 2f. And over here, instead of using a number, let's just use that variable. Now, if we were to get back to this code after a long time, it would be extremely clear what this parameter represents. The technical term for what we did here is called magic numbers, and I've also covered them in detail in another quick video. But as a rule, always remember very simply, never use magic numbers. Okay, so with this we have our raycast. It's pointing forwards for this distance. But this is actually not very useful, because the raycast, this one only returns a boolean. So all this tells us is if there's something in front or not. It does not actually get us the actual object reference. So for that, let's use a different version of the raycast function. So as you can see, we've got all kinds of versions. In order to get the object reference, let's use this version right here. This one, which has an out parameter for a raycast hit. Note the out keyword here, this is important. This means that this is an output parameter, whereas the other parameters, those are all essentially inputs that you give to the function, whereas this output, this is basically a value that the function outputs. So let's use this. So we've got the origin, we've got direction, then we've got the raycast hit. In order to use it, we need to make sure to write the out keyword here. And then also very important, we need to write the type. So let's call it raycast hit. And then the name, so let's call it raycast hit. Basically what we're doing here is essentially defining a variable of this type with this name. We're defining it and giving it to the function immediately so we can use it afterwards. If you don't include the type, if you just include the name, then you get an error because this name, raycast hit, this was never defined. Alternatively, you can define it before you pass it in. So over here, you can do a raycast hit, and just like this it works because you are defining it here and using it here. But in order to make the code a bit more compact, you can just define it here in the same place where you get it. Okay, so let's use this. And with this, the function still returns just a boolean, so just hit something or not. But then we've got the raycast hit output. This will be filmed with data from the collision if we do hit something. We can inspect this to see what data it contains, so you can right-click on top of the type, and then go to definition. And up here we do see the definition for the raycast hit struct. You can see this is a structure to get information back from a raycast. You can inspect this to see all of the kinds of things that this one returns. For example, you have a vector3 point for the impact point in world space where the ray actually hit a collider. You can get the normal of the surface and so on, so you can get all kinds of things. For our use case, what we want is to identify the object that we hit, and for that we can use the transform. So this is going to be the transform of the rigid body or the collider that was hit. So let's just do a quick test. If we hit something, let's do a log on that object. So let's do an if. So if this one is true, then that means we hit something. So if so, let's do a debug.log, go inside the raycast hit, and log the transform. Okay, so like this, we should be able to see on the console if we do hit something. Let's also do an else, just to be able to easily see when we hit something. So on else, let's just log an empty dash. And in our game, in order to make sure that our collision is working, that we are correctly detecting it, let's just duplicate this object. But before we do, let's make this a proper prefab. If you have an object of a certain type that you want to create multiple instances of it, you should be using a prefab rather than just duplicating an object. That way with the prefab, if you make any changes to that prefab, it applies to all of the copies of that prefab. So let's first make this one a prefab. And again, since this is our first prefab, let's first make a nice folder to keep things organized. So a folder for our prefabs. And to make a game object prefab is super simple. You just click and drag directly from the hierarchy and drop it inside the folder. There you go. There's our prefab. And now let's just duplicate this. Make sure it has a different name. So it has a 1, so that's enough. With this, we should be able to see it just for testing. Let's put it just off to the side. Okay, so let's see. So here we are, and on the console we see a dash. So by default, we are not hitting anything. Okay, so that makes sense. Now if I move towards this object, and if there you go, it does identify that object. And if I stop moving, it stops identifying. Okay, great. Now if I move towards this one, and if there you go, this is the one with the name of 1, and this is the one with the name of none. All right, awesome. So just like this, we are correctly identifying what object is in front. Except we also have an issue. So if I move towards the object, then yep, it does work. But if I stop moving whilst I'm still facing that object, right now it's returning none. Now the reason for that is because of the move dir that we're using here. If we're not moving in any direction, then basically this vector will be 0, 0, 0. So we're going to be firing a raycast towards no direction at all, so obviously it's not going to hit anything. The solution to that is super simple. We just need to keep track of the last interact move direction. So let's go up here, define a field for that. So let's make a private. Let's make a vector3 and call it the last interact direction. And then down here when we have our handle interaction, so we get the movement here. Okay, that's great. So then we just check if the move direction is different from vector3.0. By the way, this is a constant, a shorthand for 0, 0, 0. So if it is not 0, then that means we are moving in some direction. So if so, let's set the last interact direction to this move direction. And basically if it is not, if move here is 0, then we are not going to modify this. So this one is only going to contain the last interact direction. And then down here, instead of using the move direction, let's just use this one. So that way, even when we stop moving, we are still going to be using the last interact direction. Okay, so with this, let's test. So here we are, and if I move towards it, yep, it works. And if I stop moving, and yep, it still works. All right, great. So we can move towards it, point towards a certain object, and then, yep, it still works. Okay, great. Now let's actually interact with this counter. And to do that, let's make a class for the counters themselves. So let's make a new script, a new C# script. Let's call it the same name, so clear counter. Okay, there's our script. Now, very importantly, for attaching the script, remember that we have two instances of our prefab. If you just select it in the hierarchy and you just drag it on there, if you do that, then you're not actually adding this script to the prefab itself, you're only adding it to this specific instance of that prefab. So if you look at this one, yep, it has a script, but this other one, which is a copy of the same prefab, this one does not have it. Also over here on the inspector, you can see the little script icon has a nice little plus. That means it is something that you are adding on top of the prefab. So that means this script is not present on the base prefab. Basically, this is not what we want. We don't want just this object to have this script. We want all instances of this prefab to have this script. So instead, let's get rid of this one from here. We want to modify the prefab itself. So one way to do that is to select the prefab on the project window. So here it is, the actual prefab. And now we can drag the script on there. So that works. Or another alternative is select the prefab in the hierarchy. And on the inspector over here, we see a nice button to open the prefab. And if we actually go into scene view, then we can see what that does. So with the object selected, so this is an instance of that prefab. But if we click on open, then essentially we are opening and we are working inside the prefab. So now if we make sure to add our script, and let's go back outside this prefab. So on the top left corner over here, we can see where we are. So we were inside our scene and then we are inside the clear counter prefab. So if we click on the scenes, we can go back. Now it tells us that we made some changes to the prefab, so let's save them. And yep, we added that script and we can see both instances of the prefab, they both have the same script. And we can see on there on the icon that this is not an override. This is an actual script added on the base prefab. So whenever working with prefabs, always make very sure that you are adding it on the right place. If you want something on the base prefab, make sure you either add it on the prefab itself, or go inside the prefab by double clicking on it, or select an instance in there and open to go inside the prefab. So always keep in mind differences between a prefab and an instance of a prefab. Okay, so we have our script, let's open it. And over here, let's just make one super simple function. So let's make it public because we want to call this from our player class. Let's return void and just call it interact. Okay, that's it, super simple. For now, let's just do a debug.log and just say interact. Okay, so that's it. And now over here on the player, when we have our handle interactions function, so we interact, we do our raycast, and we find out if we hit something. So when we do, the first thing that we should do is identify what this transform is. So is this something just like a dumb cube, or is it an actual counter? Now when it comes to identifying things, this is another place where a lot of beginner tutorials would teach you to use the Unity tag system. So that's over here in the editor when you select any object. Over here in the inspector you can see a tag, so you can see untagged and you can add all kinds of tags. This is something that a lot of beginner tutorials teach, but Unity tags are horrible. You should never use them. I covered in more detail why that is in the advanced concepts video. The main reason is because of, well, pretty much the same thing that I mentioned a while ago when we were handling animator parameters. So we were doing this and I talked about how this one takes a string and how strings are a horrible way for identifying objects. They are very brittle, very error prone, it's very easy to make mistakes. And tags have the exact same problems because tags are strings. So we do not want to use tags to identify objects. Instead, over here on the player script, let's use a different method for identifying objects. And the best way to do that is to simply get our counter component. So we have our transform, and then from inside that transform, we can call the function try_get_component. This one then takes the type of component. And again, note how this is an out parameter. So let's put out, and we want to test if this is of type clear counter. So clear counter, and call it clear counter. And this one basically does the same thing as a raycast. So it returns a boolean, so either true or false. So if this one is true, then that means that object has that component. So over here we know has clear counter. By the way, if you're not familiar with try_get_component, this is pretty much the same thing as the regular get component, except it automatically handles the null check for you. So if we just do this, it's exactly the same thing as this. So you do an if raycast hit, let's access the transform, get component of type clear counter. And actually this one is not inside an if, but let's store this. Clear counter equals this. Then you do if this one is not null, then we know has a clear counter. So basically what we have up here is the exact same thing that we have down here. So just using try get component, it's just a bit more compact and I find much easier to read than to always get the component and test if it is not null. Over here we just have one function with a nice out parameter and everything works perfectly. So that's the try get component. I much prefer that method, so let's use that. By the way, on the try get component, over here you can see it has a type inside some angled brackets. Basically these are called C# generics. These are an extremely powerful C# tool. I have a dedicated video on them and I've used them in tons of videos. Definitely go ahead and learn about them. Basically this lets you write code that works with many classes, not just one specific type. In this case, the try get component can work with any type of component. So it can be Unity built-in components or it can be components that you made yourself. Then if it finds a type, it returns true. So for right now, it's not strictly necessary to know the specifics about how C# generics work, but definitely make sure you add that video to your queue and watch it afterwards. C# generics are an extremely useful C# feature. Okay, so we do this, and basically if we are inside of here, then we know this object has a clear counter, and we have our clear counter reference. So over here, it's super simple. Let's just call the interact function. Alright, so that's really it. Let's just get rid of the else. We no longer want that log, so we should be able to see a log whenever we call our interact in a counter. Alright, so here we are, and if I move around, okay, that's good. Over here the console is empty, alright. Now if I move towards the counter, yep, there you go, I'm interacting with it. And if I move towards this one, yep, there you go, interacting. Alright, great, so with this we are correctly identifying the object and interacting with it. Now let's just do one final thing. Over here we are doing a raycast to find the counter. And right now we are doing a raycast towards any object that has any kind of physics collider. So maybe that's our counter, or maybe it's just a random wall. For example, if we had an invisible wall in front of our counter, then this code would not work. That's because this raycast and this raycast hit, it only returns the very first object that it does hit. So if the counter was behind a wall, then the raycast hit object here would be a reference to that wall object. Perhaps that's what you want, or perhaps not. In that scenario, one thing you can do is instead of using raycast, you can use the function raycastAll. And difference for this one is instead of returning just a boolean, just true or false, instead it returns an array of all of the objects that it hit with that raycast. Then you could cycle through them and identify the object. So that's one approach. Or another option is over here on the raycast. If we look at these function versions, we can see that some of them has what it's called a layer mask. Basically, you can set a certain game object to a specific layer, and then if you use a layer mask, then you can make sure this raycast will only hit objects within that layer. Anything not on that layer will be ignored for that raycast. This is super useful, so let's learn how it works. For a layer mask, we can go up here and define a type of layer mask. So let's make another serialized field, private, let's make it of type layer mask. Let's call it the counters layer mask. Okay, so we have this, and then down here when we have our raycast, let's use it. So let's find the function that matches up these parameters with the layer mask. So here it is, we have the origin, then we have the direction, the raycast hit, the max distance, and then finally we have our layer mask. So let's use our counters layer mask. Okay, great. Now back in the editor, let's select our player game object, and yep, there we see our field of type layer mask. And you can see how we can select all kinds of layers, and how we set these layers to an object is, let's just select our clear counter. Although again, we want to make sure that this change applies to all counters, not just this one specific instance. So let's go inside the prefab. And over here, we've got a field for our layer. And you can see we've got a bunch of default layers. And then we can add some more. So let's add some layers. And over here, let's go to the first empty one. And let's call it counters. Okay, we've added the layer. So let's go back, select our object. And now on the layer, let's put it on the counters. Now it asks you if you want to modify the layer for all child objects. Now, since we made sure to keep the logic and physics components only on the parent object, let's just modify this one and leave the other ones on the default. So let's just modify this object only. Okay, so with that, our counter is now on the counters layer. Let's leave the prefab, make sure to save it. Okay, great. And now if we go back into the player and over here on the counters layer mask, yep, we do see the counters layer. So let's just click the selected. By the way, this drop-down menu, you can actually select multiple. So you can select all kinds of layers, so this is multi-select, but we only want the counter, so only like this. And just like this, if we do test, and now if I move towards it, and if there you go, got the nice interact on both of them. So everything still works exactly the same, but now if we had another physics slider in front of it, it would still work because we're using a layer mask to only raycast against counter objects. Alright, great. Now I should point out another way to work with layers is with something called a bit mask. That's a bit more advanced. Usually the layer mask is much easier to follow, but if you want to learn about bit masks, go ahead and watch that video. And also another quick note, in this game we're only going to interact with one single object type. It's only going to be a counter, even though we're going to have multiple types of counters. But for games where you want to interact with multiple objects, like for example having an interact action to talk with an NPC, and another one to open a door or push a button, for those kinds of multiple interactions, to build a system like that, make sure you look into my How to Interact with Objects video. It covers how to do all of that, how to interact with all kinds of objects. It's all based on C# interface, which we're actually going to use in a few lectures, and also have a dedicated video on that topic. So keep following this course, but then make sure to watch those videos, add them to your watch list, and make sure you do watch them. Watch that How to Interact video. It is something that is necessary in so many games, and most tutorials don't actually teach you the correct way of doing it. Anyway, so back in our game, we are correctly identifying and interacting with each counter. But obviously we don't want to interact automatically just like this. Instead, we want to press a nice button to interact, so that means we're going to need to create an interact input action. So let's do all of that in the next lecture.